Welcome back to another one of my applications of differentiation videos. This will be the mean value theorem, and this is the fourth video in the series. So, let's first you have to match three criteria with your function if you're going to use the mean value theorem, and that is that the function is continuous on the closed interval of a to b. The function has to be differentiable on the open interval from a to b, and the function of a is not allowed to equal the function of b. If they do equal, then use the Rolle's theorem, but you don't use the mean value theorem. And if all of these three criteria match up, you use the formula. Derivative of the function of c equals function of b minus the function of a over b minus a to find the point at which so the point at which the tangent line of that point is the same as the secant line through your function, and I'll show you what I mean. So our function will be negative 5x cubed plus 6x squared plus 4x plus 5 within the domain of negative 1 and 2. Okay, what is that going to look like? Well, if I can get the function right, it's not going to be 100%, but the function should, that's x, and this is the function, which is the same as being a y value. Okay, so it starts at negative 1, let's say the negative 5. Okay, so starts at negative 1, so it's about here. That's the point. This comes in, it looks a bit funky, comes in like this, something like that. Okay, and we're going to be starting roughly here. It's not to scale, but we're going to be starting roughly there, and we're going to be ending roughly here. That shouldn't be a 5. Don't worry about these. But yeah, so this counts as R1, and this counts as R2. Okay, and we're going to draw a line, passes through them both, and we're looking for the 2 points, because we're looking for where on the function where on the function is there another slope that's parallel to this. And in this case we have 2, because you come up, you're following the function, and you have one that's parallel there. Oh, that's not parallel, but that's parallel. And then it comes up here, and that's supposed to be rounded, and you end up with a function that's about here that's parallel. So you got two x coordinates where at those points the slope is the same as the slope that runs through the points of negative 1 and 2. Okay, so let's get on to it. So we have our function. Okay, first step, this is going to be a, and this is our b value. So we'll write that out. A equals negative 1. Therefore, if we sub a into the function of a, the answer is 12. B value is equal to 2. We sub that value into the function, and it equals negative 3. Therefore, f of b minus f of a on b minus a will now equal f of b, which is negative 3, minus f of a, which is 12, all over b, which is 2, minus a, which is negative 1, which will in turn equal negative 5. Okay, so we have that value. Now we need to find the derivative of the function of c. So function c is the exact same as that. We just fill in we replace all the x's with c's. So it'll be negative 5xc squared cubed it'll be negative 5c cubed plus 6c squared plus 4c plus 5. And now we've got to derive it in order to find the derivative of f of c. Derive that, we get negative 15c squared plus 12c plus 4. Okay, so we have this bit and this bit of this formula. So this side is equal to negative 5, as shown here, and this side is equal to this. So I'm going to put them both together. Okay, so that'll be, what's that there? That's negative 15c squared plus 12c plus 4. Yep, and that equals negative 5. Okay, so what can we do with this? Well, we've got negative 5 here and we've got a positive 4 here. So if we add 5 to both sides, we end up with negative 15c squared plus 12c. That doesn't change, but when we add 5 to both sides, we end up with positive 9, and this side has 0. And that's what we want, because now we can use the quadratic formula to solve, because if anyone's familiar with the quadratic formula, ax squared plus bx plus c equals 0, and use the quadratic formula to find the x value, or values, which is equal to x, so equals negative b plus or minus the square root of b squared minus 4ac all over 2 multiplied by a. Okay, so this is what we're going to use. Well, I'm not going to do it for you, because you should know how to use the quadratic formula by now. I will do a video on the quadratic formula, but I'm not going to bother with it. I'm just going to show you what you come out with. So if you use the quadratic formula and you sub these values in, you should get C1 should be approximately, because I didn't get it's a decimal and I just rounded it, so it's approximately negative 0.47, and C2 is approximately 1.27. Okay, so these two, at those 2 points, I know I did a sloppy job on here, but essentially it's supposed to be at C1 at 0.47, the slope is supposed to be equal to the line, the tangent line, and at 1.27 the slope, it should be there, but hopefully you get the idea. I'll redraw it for you. So you have negative 1, and you have 2, and it's supposed to come in oh, that's terrible. That's terrible. The whole I can't draw graphs obviously, but the whole point is that at C1 and C2, which are these values here, the x values, the slope at that point will be the same as this slope passing through from this point to this point. So hopefully that makes sense. If you've watched my other videos on mean value theorem, it should make sense. I just can't draw these obviously, but yeah, I have maybe that'll help. I have it in my book. That's a better drawing. But anyway, hopefully this video helped you. Thanks for watching, and I hope you have a good day.